Welcome to today's deep dive. Our mission right off the bat is to unpack two incredibly dense, absolutely mind-bending preprints from May 2026.
Yeah, they really are dense.
Right. And they were published by Christy Seeley and Brad Yoakum, who are part of the RPC collaboration. And these papers, they're titled The Near-Extremal Kerr Universe and Recursive Partition Cosmology. And the whole reason we're dedicating this entire deep dive to them is that these authors are claiming to have solved, well, arguably the most embarrassing foundational problem in modern physics.
Yes.
And their solution, it requires absolutely no new physical particles.
Right, which is just a massive deal. I mean, they are taking it a monumental cosmological crisis and treating it not as, a missing piece of matter, but as a pure arithmetic theorem.
Yeah.
Which is a radical paradigm shift.
Okay, let's unpack this because to understand the sheer scale of the crisis they're trying to solve, you really have to think about margins of error.
Yeah.
Usually when we talk about a scientific error, there's a predictable scale. Like, if you're engineering a bridge to the moon and your math is off a tiny bit, maybe you miss your landing spot by, I don't know, a few miles.
Yeah, exactly.
It's frustrating, but it's comprehensible.
It's a margin of error. It's measurable and usually fixable with just a slight recalibration.
Right. But then you step into the world of theoretical physics, specifically quantum field theory, and suddenly that margin of error isn't a few miles. It is the absolute definition of a mathematical catastrophe.
Oh, absolutely.
We're talking about the cosmological constant anomaly. Quantum field theory predicts that if you look at the empty vacuum of space, the energy bubbling in that vacuum should be roughly 10 to the power of 113 joules per cubic meter. But when astronomers actually look out into space and measure it, the observed value is 10 to the negative 10. That is a discrepancy of 123 orders of magnitude.
It is the largest quantitative error in the history of physics. Without question. I mean, if quantum field theory were entirely correct about vacuum energy, the universe would have expanded so violently and so rapidly that, well, galaxies, stars, even atoms could never have formed.
Exactly. If you missed the moon by 123 zeros, you wouldn't just be missing the moon, you'd be missing the entire observable universe.
Right.
Like billions of times over.
Yeah.
So how has standard physics tried to fix this? Usually it involves, hunting for some invisible, exotic, dark energy or proposing brand new, undiscovered subatomic particles just to balance the equation.
Yeah, the assumption for decades has been that we're missing some massive physical component of the universe. But Seeley and Yoakum argue that standard physics is essentially looking for a physical hardware solution to a software glitch.
Oh, wow.
Yeah. They claim Einstein's field equations are perfectly fine as they are. The problem is that physicists applied those equations to the wrong foundational reference state. So the answer isn't a new particle. It's a mathematical rule set they call unity division arithmetic, or UBA,
okay.
right? Which forms the basis of their recursive partition cosmology.
And to understand how an error of 123 zeros is actually just an arithmetic theorem, we kind of have to go back to the absolute beginning, like before particles, before space even exists. If this is a math theorem, where does the math actually start?
It starts astonishingly simply. In unity division arithmetic, the framework begins with a single substrate. U equals 1.
Okay.
One universe. One total conserved state. And the only mathematical operation allowed in this entire system is division.
Just division.
Just division. You take the whole and you divide it into parts. But here is the critical, non-negotiable rule of UDA. You can never divide to reach 0, and you can never divide to reach infinity.
So wait, if I'm picturing this right, it's like, imagine I have a single massive block of clay. If the only rule is division, I can just keep cutting it in half. I cut those halves in half, and then I cut those quarters in half recursively, just forever.
Right.
But because I'm only ever dividing what already exists, I can never have exactly 0 clay.
Precisely. Banning 0 in this math means that a perfectly empty vacuum is completely banned from existing in the physical universe.
Oh, wow.
You can never have absolute nothingness.
That makes total sense. And on the flip side, because I can't somehow cram an infinite amount of clay into a single point, because infinity is also mathematically banned, right? Then true black hole singularities are impossible too.
Exactly. Both 0 and infinity in this framework are just artifacts of physicists applying mathematics outside of its natural domain.
Yeah.
Nature doesn't do zeros, and it doesn't do infinities. It only does fractions of a whole.
Okay, so we're recursively slicing this cosmic block of clay, generate all the fundamental structures of the universe. But here is where the clay gets incredibly messy, right?
Yeah.
Because the papers explain that as the universe recursively divides down into three-dimensional space, what they call harmonic level 5, it tries to pack fundamental geometric shapes together. Specifically tetrahedra, which are basically 3D pyramids with triangle faces.
Yes, and this is where the arithmetic hits a very physical structural wall. If you take 5 regular tetrahedra and you try to pack them together around a single common edge, their internal angles add up to 352.65 degrees.
Okay.
But a full circle is 360 degrees.
So they don't perfectly close. You're left with a 7.356 degree gap.
Exactly. And because they can't perfectly close, the geometry undergoes what the authors call frustration.
Restoration, I love that.
Yeah, it's a great term. This packing failure creates structural defects, stable geometric holes, and essentially all the complex geometry we perceive in the universe.
What blows my mind is that this isn't just some abstract whiteboard failure, this is physical. Because those little pyramids don't close, the universe is left with a literal crack in its foundation.
What's fascinating here is that this tiny, microscopic geometric gap dictates not just the physical shape of the cosmos, but the actual flow of time itself.
Whoa, hold on. Time. Are you telling me that a geometric gap, basically a microscopic packing error with triangles, is the literal arrow of time?
Yes.
You're gonna have to break that down for me, because that sounds like a massive leap from a structural gap to the passage of time.
It is a massive leap, but the causal link is stunning. To understand the temporal aspect, we have to look at the frequency equivalent of this 7.356 degree spatial gap.
Okay.
In unit division arithmetic, this spatial gap is mathematically identical to something called the Pythagorean comma.
Okay, like in music theory.
Yes, exactly.
So the universe is essentially a slightly out-of-tune piano.
I know it sounds almost too poetic, but they mean it quite literally as a structural mathematical necessity.
Yeah.
In music theory, if you take the prime number 3 and stack 12 perfect fifths, mathematically they do not perfectly align with 7 octaves, which are based on the prime number 2. There is a mathematical residual leftover. It's a ratio of 1.0136, or about 23.46 cents in musical tuning. It is structurally impossible for the prime numbers 2 and 3 to perfectly span the prime number 5.
Wait, really?
Yeah, you simply cannot express one as a perfect ratio of the other.
Because they're incommensurable. Like how the square root of 2 is an irrational number that just goes on forever. You can't pin it down as a neat, perfect fraction.
Exactly. This spatial gap of 7.356 degrees is the three-dimensional shadow of that same irreducible mathematical incompatibility. It's a math problem that literally cannot be solved.
Okay, but how does an unsolvable math problem create time?
Because the universe wants to reach a perfectly stable zero-energy state. It wants to freeze into a perfect static crystal. But because of this Pythagorean comma, the math forbids closure.
Ooh.
The universe tries to pack the tetrahedra together, hits the gap, fails to close, and is forced to instantly update or shuffle its geometry to try and balance the equation elsewhere.
It's just constantly shuffling.
Right. This relentless, continuous shuffling, what the authors call the partition update rate, is the arrow of time. Time only moves forward because the universe is endlessly trying and failing to perfectly divide itself.
It's an engine. Time isn't some invisible river we're floating in. It's the exhaust of a universe frantically trying to balance an unbalanceable checkbook.
That is a brilliant way to phrase it. Furthermore, they argue that the local partition update rate, meaning how fast a specific localized region of the universe is shuffling its geometry to try and close the gap, is literally what we experience as temperature.
Wait, temperature?
Yeah, where the update rate is frantic and high, the temperature is higher. That shuffling generates entropy and creates the boundaries of what we see as matter.
Okay, so if the universe is this constantly shuffling engine, endlessly churning to close an unclosable mathematical gap, what is its actual physical overall shape? Like, what does all this division and cycling look like if you could step outside of it?
Well, this is where Seeley and Yoakum offer a radical reinterpretation of our cosmological model. According to their papers, the observable universe is not a static, flat plane expanding in all directions into nothingness.
Right.
Structurally, the universe behaves as a near-extremal Kerr rotating black hole.
Here's where it gets really interesting, because earlier you mentioned that standard physics got that 123 order of magnitude error because they applied Einstein's equations to the wrong foundational reference state.
Right. Let's unpack exactly why standard physics gets it so wrong. Standard quantum field theory calculates the vacuum energy by assuming the universe's baseline state is flat, empty, non-rotating space.
Okay.
If you sum up all the quantum fluctuations in a static vacuum, the math runs away from you and shoots up toward infinity, giving you that massive 10 to the 113 number.
Because it's treating the vacuum as a blank canvas standing completely still.
Exactly. But if you treat the observable universe as a spinning black hole, specifically an extremal Kerr black hole, which means it is spinning at the absolute maximum theoretical limit, the physics change completely.
Wow.
Yeah. In a maximally rotating black hole, the surface gravity at the event horizon drops to near zero. And because the surface gravity drops to zero, the Hawking temperature of that horizon drops to near absolute zero.
How cold are we talking?
Specifically about 10 to the negative 36 Kelvin.
Okay, so how does a background temperature of 10 to the negative 36 Kelvin actually fix the massive error?
Because when you plug a hyper-rotating ultra-cold boundary into the equations, instead of a static flat vacuum, the sheer geometric suppression of that extreme rotation effectively zeroes out the thermal noise.
It just zeroes it out.
Right. By simply using this correct rotating reference state, the math automatically removes 111 orders of magnitude of that massive error.
That's insane.
It's not a tweak or a hack. The spin geometrically suppresses the error as an exact mathematical theorem.
Boom. 111 zeros just vanish because we stopped assuming the universe was standing still. The extreme spin basically freezes out the quantum noise. But wait, 123 minus 111 leaves 12. Nature doesn't just sweep 12 zeros under the rug. How does the universe account for the remaining 12 orders of magnitude?
They are precisely accounted for by the 12 steps of the Pythagorean harmonic hierarchy.
Okay, you're gonna have to explain that.
So in the UDA framework, the universe organizes its information into 12 harmonic levels of scale. It starts at the absolute bottom, the Planck scale, which is the smallest possible physical length, and scales all the way up to the cosmic horizon, which is the entire observable universe.
Okay, so 12 steps.
Right. Each of these 12 levels is separated by a factor of roughly 10 to the 10th in energy density. The 12th level, the final step, is the Pythagorean comma itself. It's the point where 12 perfect divisions fail to return to unity.
So the residual leftover discrepancy, those final 12 zeros,
Is the exact holographic information limit of the universe.
oh my gosh.
Yeah. In physics, the holographic principle states that the maximum amount of information a 3D space can hold is dictated by its 2D surface area. The papers argue that those 12 leftover zeros represent the absolute maximum information density the universe can geometrically hold, dictated by the Pythagorean comma.
Wow.
So the cosmological constant, which standard physics thought was some mysterious dark energy, isn't an anomaly at all. It is the Pythagorean comma writ large across the cosmos.
So this entire time, physicists have been staring at the cosmological constant, thinking it's an invisible force pushing galaxies apart, when in reality it's just the arithmetic residual, like the ultimate rounding error of the universe's geometric limit.
Exactly. It's not a fine-tuning problem requiring new exotic particles. It's a strict arithmetic theorem.
Okay, the math is incredibly beautiful. The music analogy is blowing my mind. But theoretical physics requires observational proof, right?
Always.
If the universe is this giant rotating Kerr black hole driven by a mathematical gap, where can we actually see this shape in the wild?
To visualize this, we have to look at the flow lines of this rotating universe. The authors explain that the universe flows in the shape of an involutive toroidal vortex, and the matter flows along paths called Villarceau circles.
Hold on, my brain is melting a bit at involutive toroidal vortex and Villarceau circles. Can we ground this? Are we basically talking about a donut shape here?
Yes, essentially a torus or a donut.
Okay, let me try to picture this in motion. It's like a massive smoke ring, right? But the smoke ring is constantly turning inside out on itself, rolling and flowing continuously. And if I understand the math right, because of that Pythagorean comma, because the prime numbers don't perfectly align the flow of the smoke, never perfectly overlaps its previous path. It dense packs the surface of the donut infinitely, but never completely closes the loop.
That is a perfect visualization.
Yeah.
If you slice that donut at a very specific diagonal angle, you'd get two perfectly interlocking circles. Those are the Villarceau circles.
Okay.
And because this irrational flow never perfectly overlaps, it satisfies a mathematical principle called the KM theorem, the Kolmogorov-Arnold-Moser theorem.
Meaning what, exactly?
Meaning the flow is infinitely dynamically stable.
Yeah.
Because the gap is irrational, the system won't resonate itself apart or degenerate into chaos. It is robust against physical perturbations.
Right, okay.
But to answer your question about where we can see this actual geometry in the wild, the authors point to a very specific astronomical phenomenon called Hugg's object.
Hoag's object. I've seen pictures of this. It looks like a mistake in the telescope.
PGC 54559, right?
That's the one. It is a deeply isolated ring galaxy. It has a bright, solid elliptical core of stars, and then a massive 70 kiloparsec completely empty gap of void, and then a perfect outer star-forming ring rotating at 270 to 300 kilometers per second.
And it is so strange because it has no spiral arms, no connecting bars between the core and the ring, just a core, a massive void, and an outer ring. Right. And the standard model of galactic evolution struggles to explain how a galaxy could maintain that perfectly disconnected ring shape for so long without it collapsing into spiral arms.
Yeah.
But Seeley and Yoakum claim that Hugg's object is the ultimate ground state of the universe made physically visible. It has been incredibly isolated from other galaxies for over 10 billion years, sitting in a 3 megaparsec isolation radius. With no external gravity interfering, it has had time to relax into the universe's pure UDA geometric flow topology.
So it's basically a miniature, perfectly observable model of the universe's fundamental geometric shape.
Exactly. And that massive 70 kiloparsec empty gap between the core and the outer ring. That is the physical manifestation of the unclosable stable hole predicted by the arithmetic.
Wow.
In the geometry of a torus, its equatorial projection forms a shape called a cardioid, which looks like a heart shape.
Oh yeah, a cardioid.
Right. The inner point of that heart is called a cusp. The math dictates that this cardioid cusp is a forbidden region, because 0 is mathematically banned in UDA. Matter literally cannot enter or exist in that 70 kiloparsec void. They orbit around it, but they can never enter it.
So Hugg's object is just casually demonstrating the mathematical ban on 0 out in deep space?
Yes.
That is staggering. But look, as mind-expanding as this is, it sounds almost like brilliant philosophy at this point. Music math, clay splitting, cardioid shapes.
Sure.
But these authors are so confident in this theory that they haven't just published cosmological papers, they've actually designed physical hardware to test it, right?
They have. This is where the paper transitions from theoretical cosmology to applied engineering.
Amazing.
The authors have actually filed patents for physical devices based on this UDA math. Two of the main ones are the QLA, which stands for the Quantum Lagrange Array Gravitational Interferometer, and the BBG-SVG, which is a buckyball stabilized superfluid vortex gyroscope.
Okay, those sound like items you'd find in a sci-fi villain's underground lair. What do they actually do, and how do they prove the math?
To understand the hardware, we have to look at one more geometric property of this arithmetic. When the universe divides, it naturally creates a three-phase system. Think of the classic 3-4-5 right triangle from geometry.
Right.
That first baseline division creates three phases separated by 120 degrees. The authors argue that the cosmic web, the giant filaments connecting all the galaxies in the universe, acts exactly like a three-phase electrical system. They claim the plasma in those filaments behaves as a collisionless superfluid, carrying quantized electrical currents along massive magnetic field lines.
Hold on, when you say a three-phase electrical system, my brain immediately goes to the industrial power lines on my street or the motor in a heavy-duty washing machine. How does an earthly power grid map onto galaxies? And what even is a collisionless superfluid?
Let's break that down. A collisionless superfluid is a fluid that flows without any internal friction whatsoever. Particles don't crash into each other, they just glide perfectly. The authors are saying that the cosmic web's plasma flows along magnetic lines in three distinct interlocking waves, exactly like the three alternating currents flowing through an industrial power grid. They're separated by exactly 120 degrees of phase. In a standard three-phase system, you can connect the electrical currents in a triangle shape, called a delta configuration, which represents the outer flow of power. Or you can connect them to a single common center point, called a Y configuration.
And what does the Y configuration represent in space?
In the cosmos, the Y configuration represents the cosmic voids, the massive empty spaces between the galaxy filaments. In a Y configuration, the center point is called a neutral tap, where the three electrical phases perfectly cancel each other out, leaving a completely quiet zone.
Okay, so how does the QLAG device actually test this? Are we flying out to a cosmic void?
No, we can test it right here in our solar system. The QLAG arrays are designed to be placed at the Sun-Earth Lagrange points, specifically Lagrange points L4 and L5.
Ah, because L4 and L5 are located exactly 60 degrees ahead of and 60 degrees behind Earth in its orbit around the Sun.
Precisely. 60 degrees is exactly halfway across a 120-degree three-phase angle.
Wow, okay.
The authors claim that L4 and L5 act as the gravitational neutral taps of our solar system's own local three-phase flow. They are the quietest possible spots, where the local gravitational frame dragging of the Sun and Earth perfectly cancels out.
So by tapping L4 and L5, they are essentially plugging into the neutral center of the Earth-Sun system's power grid.
Exactly. By putting highly sensitive devices called Bose-Einstein condensate masers at these specific points, they predict we can measure a very specific tiny discrepancy in the gravitational constant between these void equivalent points and the Earth.
A discrepancy of about 1 part in a trillion, right? Which is exactly the numerical size of the Pythagorean comma.
Exactly. Now, this raises an important question. How do we know this isn't all just a massive mathematical coincidence? A grand case of pattern matching where they are just forcing the numbers to fit.
Right, because if I look hard enough at a burnt piece of toast, I can find the golden ratio or the face of a celebrity.
Right.
Skepticism is healthy here.
That's where falsifiability comes in, which is the gold standard of science. The papers don't just reinterpret old data to fit their model. They offer 6 specific, falsifiable predictions that are testable within this current decade using existing technology.
Give me the highlights. If astronomers are looking up right now, what should they be looking for to prove this right or wrong?
For one, they predict that using data from the Euclid and Planck satellites, astronomers will find a preferred cosmic spin axis. Standard cosmology dictates that the universe should be isotropic, meaning it should look exactly the same in all directions with absolutely no preferred spin or orientation.
Right.
But this framework says the universe is literally a rotating Kerr black hole, so it must have a preferred axis of rotation, which should align with subtle anomalies we've already hinted at in the cosmic microwave background.
And the second big prediction?
The Gaia proper motion residuals. The Gaia Space Observatory maps the exact, minute movements of billions of stars. If our solar system is genuinely flowing along these three-phase Villorso circles, there should be a tiny, highly specific three-phase cardioid pattern hidden in the residual movements of stars over a 178.7-year cycle.
Oh, wow.
Standard dark matter models predict that any residual movement should just be random, isotropic noise, but UDA predicts an exact interlocking 3 cardioid shape mapped across the sky.
So they're fully putting their money where their math is. If the Gaia data doesn't show the cardioid shape, or if the Euclid satellite doesn't definitively find the cosmic spin axis, the whole theory breaks.
Exactly. It is entirely relentlessly testable.
So what does this all mean? We have gone from the largest mathematical error in physics to musical commas to rotating extremal black holes to three-phase power grids hidden in space. If a listener is driving to work right now or taking a walk, how do they internalize this fundamentally different view of reality?
If we connect this to the bigger picture, it means we exist inside a highly stable, self-referencing engine. It is cam-stable, meaning it cannot be broken or torn apart by minor physical perturbations. The things we perceive as massive, incomprehensible errors, like the 123 order vacuum energy anomaly or chaotic mysteries in physics like dark energy, are actually profound structural necessities.
They aren't bugs in the software, they are the core features of the operating system.
Precisely. A good analogy is a quasicrystal. A quasicrystal has an ordered structure, but its pattern never strictly repeats, precisely because of irrational geometric gaps.
Right.
Without that Pythagorean comma, without that tiny 7.356 degree failure to close the loop, the universe would perfectly satisfy its energy requirements. And if it did that, it would become a static, frozen block of perfect geometry. There'd be no need to update, there'd be no entropy, no movement, no time, and no us.
Wow.
We literally owe our existence, our biological entropy, and our entire sense of time to a geometric rounding error.
A geometric rounding error. It really does profoundly change how you look up at the night sky, or how you look at a simple block of clay for that matter. But, thinking about those QL arrays, placing devices at the Lagrange points to measure this baseline gravitational coupling, it brings up this wild final thought for me.
What's that?
The authors state very clearly that the universe cycles, generating time and generating entropy, strictly because this 3D mathematical gap cannot close. The universe is desperately trying to balance the equation, failing, and that effort is what we experience as time.
Right.
So if humanity uses this new math to eventually engineer a highly localized environment, perhaps using those very big Mazar arrays out at L4 and L5 where we technologically force the gap to artificially close, what happens? Does time just stop locally inside that machine? Or do you just drop out of the physical universe entirely? Welcome to